Today we're going to take a step back from calculus and check out some complex analysis. In this problem, we have e to the 1 plus i3pi over e to the negative 1 plus i pi over 2. Using Euler's formula, we know that e to the imaginary anything, right? This is just a blob. And so we know that e to the imaginary anything is equal to cosine theta plus I sine theta. So if we have e to the I x, it's cosine x plus I sine x. Or in this case, we have e to the negative 1 plus I. This is going to be your theta. So anything you have after your I is going to be written in this form. And this is just another way to look at it, to break that exponent down. Because when you start getting into complex analysis and when you go around the circle or whenever you get into the imaginary plane, the e to the imaginary exponent takes you around the circle. And you'll get more into that. So this problem isn't terribly hard, just recognizing little features like that. Also, we know that if you have anything to the exponent, anything raised to a power, and there's addition in the power, you can break it up by multiplying the two. So x2 plus x squared plus 1 is equal to x squared times x to the first. All right, so now that we know those, we're going to get right into this problem. So first of all, in the numerator, we can break this up as e to the first times e to the I 3pi. And then in the denominator, we can do the same thing, e to the negative 1 times e to the I pi over 2. Okay, and so from here, we see that we used rule, let's call this rule 2, and then Euler's formula 1. So in this case, we broke it down using 2, and then now we're going to break it down using the Euler's formula. And so we have e to the first times, now instead of e to the I 3pi, we have cosine of 3pi, plus that imaginary part, which is the sign that tells it where to go up or down, right? Same for the denominator. We're going to do e to the negative 1. But when we do break this up, remember, I just forgot, that if you have a if it's divisible by something like pi over 2, this is actually negative 1 over 2 plus pi over 2, right? They share the same denominator. So keep that in mind whenever you're breaking up your fractions. This is actually squared. So this is actually over 1 and over 1. We just don't put that. So this one's actually over 2. And so when we write this one, make sure that we put this here. Break this up the same way, just using pi over 2 and 3pi. And it does look very long right now, but don't worry. It reduces down very quick, and you'll see. So if we take a look at the unit circle, just draw a little unit circle. And we take a look at 3pi, so this is 1 pi, 2 pi, 3 pi will be over here. So our coordinates for 3 pi is going to be negative 1, 0. And then our coordinates for pi over 2 is going to be here. So 0, 1. All right. So in this top part, cosine of 3 pi, let me just put a little line through this. Cosine of 3 pi is negative 1, and then we have sine of 3 pi, which this just goes to 0. Easy, right? So you just evaluate each of those at individual points, or where they are. So cosine of pi over 2, 0. Sine of pi over 2, 1. Cool. So now we can rewrite this as e to the first times, what do you think? So times negative 1 plus 0. And then all over e to the negative 1/2, and then we got 0 plus that imaginary 1. Because since we have a 1 left here, and that was an I times the sine of pi over 2, it's I times 1. So make sure you do not forget that you do have an imaginary number in the denominator, okay? So once we have this, we know that this is now negative e to the first over e to the negative 1/2. We can also bring this negative exponent up to the top, because when you have a negative exponent, so e, say we have x to the negative squared exponent, we can rewrite this as, 1 over x to the negative 1/2, or the negative squared. We can bring it up to the numerator as just x squared. So kind of like an inverse function, okay? And so from this we get negative e times e to the 1/2, okay? And then we can also combine this as e to the 2 over 2 times e to the 1/2. Make sure you put that negative, which is equal to e to 3. Perfect. When you combine these, you add the exponents, and then that's why you get that number up there. So I'm just checking everything looks good. Perfect. Awesome. And here's your answer.